This presentation will explore the historical, recent and ongoing developments surrounding a more integrated primary curriculum, in which opportunities to place links between subjects alongside values and broader areas of learning is the key focus across curricular education. This presentation will focus primarily on the integration of mathematics and science and will later include links to information communication technology, ICT. It is important to explore the use of ICT as a systematic motivator and to consider how this motivator can be used as a platform to further enhance a cross-curricular education, as technology is very much a part of the child's world. Examples of the use of ICT can in fact be seen throughout the following presentation. According to Barnes in 2011, he claims that our experience of the world is cross-curricular and that our understanding of the world comes from multiple perspectives. This is further supported by Gardner in 2006, who claims it is a misconception to believe that each subject can only be approached in one way. Whilst he claims it is not necessary for them to be approached in 6 or 7 forms, he states any topic of significance can be presented in a number of different ways. Rowley and Cooper 2009 also further supported this and found that in practice, different ways of seeing the world used by different subjects made themes more inclusive, enabling children to respond better. They also claim themes can be more imaginatively and successfully linked to a number of different subjects. According to Hayes 2010, arguments for cross-curricular learning come from theorists who hold a constructivist view of learning. That is the belief that children learn from direct experience. Historically, cross-curricular learning has a long pedigree. The 5 Haddo reports published between 1923 and 1933 made recommendations which would shape the national education system. In the 1931 report, the committee favoured the project or topic approach to be within the curriculum and suggested the concept of separate subjects taught in distinct lessons should be reconsidered. In 1987, the government published the National Curriculum, which divided the curriculum into discrete subjects. This therefore made the concept of integrated topic and project work favoured within the Haddo reports incredibly difficult, if not impossible. Beyond this, and perhaps the most damaging outcome, teachers and schools became demoted to curriculum deliverers. The teaching of discrete subjects as opposed to project or topic work was further supported by the 3 wise men in 1992, who concluded that whilst there is a place for topic work when it is well planned, more emphasis should be put on the subjects of the national curriculum. Dewey, 1902, disagrees, seeing the world as fluid and fluent. He claims that a child's experience of the world is not classified, and in schools, facts are torn away from their original place in experience and rearranged with reference to some general principles. If teachers emphasise the separation, it can establish artificial barriers, and children may fail to make connections between knowledge components. In 2009, the Rose Review recommended cross-curricular learning as a means of securing high standards, essential knowledge and skills. This was supported by Mauder in 2007, who found cross-curricular skills appear to have more in common with academic achievement than with intelligence, suggesting that they are quite educational. The Rose Report continued to suggest that effective learning could occur between subjects and in mixtures as long as the standards of individual subjects were improved through separate teaching. Furthermore, the report also highlighted the attention to building children's ICT skills as being crucial for enabling children to access a broad and balanced curriculum. Introduced in 2013, the new national curriculum specifically and directly draws links between maths and science, emphasising not only that the importance of maths is critical to science, but also that mathematical knowledge obtained by children should also be applied to science, alongside their understanding obtained in maths of collecting, presenting and analysing data. This suggests that naturally the 2 subjects are intertwined. An example of this natural link can be seen within measurement. Within the curriculum, children are expected to learn to measure length, weight, and capacity. Hiscock in 2012 suggests measuring skills can be taught in one of three ways. These are abstractly, where the measuring equipment is used with no context, in a maths context where there is a purpose to the task, or in a science context where some additional knowledge or understanding will be gained by carrying out the task, so motivation to carry out the task will in course be greater. Hayes 2010 supports this link between natural sciences and maths, as at the heart of being able to measure using the equipment appropriately is the ability to read a number line. In a lesson I taught in my most recent placement introducing capacity to Year 1 children, the children had to undergo an experiment to find out how many cups of water it would take to fill different jugs. Children first had to make a prediction before testing their hypothesis. This not only gave the children a purpose to their maths lesson, but it further allowed children to explore areas of maths in a scientific way. Children were enthusiastic, on task and keen to record their data accurately. Barnes 2015 claims cross-curricular approaches to be effective in good practice when individual and group motivation are built and when interests are raised. This cross-curricular practice can be continued throughout primary school. However, it is worth recognising that whilst for some children maths and science are exciting subjects that work side by side, Hiscock 2012 points out that for others the subjects are disjointed and seem to bear no relationship at all. Links between some subjects can be found with more ease in comparison to other subjects. So, cross-curricular teaching and learning can have its drawbacks. It can be ineffective when in poor practice, and according to Barnes 2015, when confusing, misleading, and when a moral context for learning isn't provided, cross-curricular approaches can be poor. This is supported by Muse and Reynolds in 2011, who point out that one of the many challenges for teachers is finding the time to plan and implement cross-curricular teaching alongside making sure pupils possess the necessary skills in order to engage in cross-curricular teaching and have regular opportunities to gain these skills. This can be insufficiently rigorous. Furthermore, in order to embed good practice, teachers must value subject knowledge, and for this to happen, a base of separate knowledge is vitally important. The three wise men found when teachers focused on single subjects, this benefited children, as topic work led to fragmented and superficial teaching, and in turn learning. Alexander 2013 found that it is the teacher's own ability of context subject knowledge alongside pedagogical subject knowledge which will translate how the subject is best translated into the curriculum experience that is right for the child. These findings put more pressure on teachers to have an efficient enough subject knowledge in both maths and science in order to meet their demands of cross-curricular teaching, and teaching outside of their standard subject knowledge, linking the three wise men who explicitly state teachers need to know more about the subjects they teach. Additionally, cross-curricular methods present challenges for teachers in terms of assessment. Noted by Hayes in 2010, whilst the Rose Report focuses on the curriculum as a whole, it doesn't focus on the primary education and it fails to take into account issues surrounding assessment. Mills and Reynolds draw attention to a common mistake that can be made by teachers. When assessing cross-curricular, this is to assume that by doing something means pupils have learned, and this is not necessarily the case. It is important, in particular for trainee teachers, to remember that the activity itself is not the learning. This is where, according to Barnes 2015, formative assessment aimed at deepening learning should form part of all creative and cross-curricular activity. This should enable the learner to appreciate their own progress and to strive for richer understanding. Barnes further believes that the less formal nature of cross-curricular learning lends itself to pupils' self-evaluation. There is the worry that children too have too much of a choice when it comes to topic or project work, and will therefore avoid areas which they find difficult and in turn become lazy learners. This links to the difficult decisions highlighted by Hayes 2012 of knowledge, skills, and understanding which are essential over those which are considered desirable. To conclude, that teaching the curriculum as an integrated whole is believed to emphasise a fusion of ideas and concepts within and across areas in attempts to make education more relevant and meaningful for children. Pupils' learning is said to be more holistic. It is believed high standards are best secured when essential knowledge and skills are learnt both through direct subject teaching but also when applied and used in cross-curricular studies. This means subjects can be complemented by cross-curricular teaching and learning that provides opportunities for children to use and apply their subject knowledge to deepen understanding. Therefore, it can be concluded that the direct teaching of essential subject content is vital but not sufficient. The Rose Review further points out the curriculum also needs to give attention to building children's capabilities with ICT. Used well, technology develops the study and learning skills of children, and in future, the potential use of technology can enhance learning and enrich across the curriculum. For example, children can use science to understand technology whilst developing skills and reasoning and ultimately linking to maths.